Hello everyone! Welcome to this instructional video on the law of sines. I know I've really been beating this into you guys, but you have a quiz coming up, so I want to make sure that you're ready. Okay, so we know we can use the Pythagorean theorem when dealing with the right triangle. But what about another triangle, like a scalene? This is when our trigonometric laws come into play. Depending on what we were given, we will use either the law of sines or the law of cosines. We use the law of sines in two instances, when you know two angles on an opposite side, or two sides and an opposite angle. Now I've already derived the law of sines for you guys, but I'll remind you of the formula. The sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. Okay, let's solve a couple of problems. For this triangle, we are given angles C and B and side B. Let's try and solve for side C. Since we're given two angles, we will use the law of sines. Alright, here we are. So we're going to solve this triangle. We have side B, angle C, and angle B, and we are looking for side C. So we have two angles, one side. We're going to go ahead and use the law of sines, as I mentioned before. We don't know anything about angle A or side A, so we'll completely disregard that part of the formula. So we know that the sine of angle B over side B equals the sine of angle C over side C. So then we'll just plug in the information that we know. Alright, so we know that angle B is 44 degrees. Reminder that we'll be using degrees this entire unit. And side B equals 7. We know that angle C, is 53 degrees. But we do not know side C. That's what we're looking for here in this problem. So the next step, logical step, would be to cross multiply. So C times the sine of 44 degrees equals 7 times the sine of 53 degrees. And then from there you can go ahead and use a calculator and solve for C. So I've got my calculator here. So there's the sine of 53. We'll multiply that by 7. So that's our right side. And then what we want to do next is divide by the sine of 44. So there's divide. There's a sine of 44. We'll hit enter and get 8.0477 and so on and so forth. But for this unit, we're going to always try and round to the second decimal place. So we know that C, or side C, is approximately 8.05 units, since we weren't given anything specific. Hopefully that makes sense to you guys. I'm going to throw it back so we can move on to the next problem. Welcome back, everyone. Hopefully the last problem made sense, because we have another triangle. So for this one, we are given all three sides and angle A. Let's try and solve for angle C. Once again, we will use the law of sines since we were given two sides and one angle. Alright guys, so we have another triangle, this time three sides, one angle. So we've got, like I said, all three sides and angle A, and we're trying to find angle C. So we have at least two sides, one angle. We're going to go ahead and use the law of sines. This time because we're looking for angle C, we're going to disregard the B component of the law of sines. So we know that the sine of angle A over side A equals the sine of angle C over side C. Like I said, just getting rid of that B component. Then we'll plug in what we know. So we know that A is 97 degrees, side A is 22. We do not know angle C, that's what we're looking for. We know that side C equals 19. There we go. So from here, we're going to go ahead, cross multiply. So 19 times the sine of 97 degrees equals 22 times the sine of C. Okay, so this one involves a little bit more computation. So first, I'm going to use a calculator and do... Here is the sine of 97, and we're going to multiply that by 19. Then what I'm going to do, is divide by 22, and you get this number here. So 0.857. So now we know that the sine of angle C equals 0.857. So where do we go from here? We have to use the inverse sine function, okay? Which means that, I'll rewrite this here, inverse sine, you can also write it as arc sine, of 0.857 equals angle C. That's what we know. So again, we're going to use this calculator. I'm going to plug it in the way it is here, that clear button. So there's 0.857, the inverse sine of that, and you get 58.98. So we know that angle C is approximately 58.98 degrees. Once again, hopefully that makes sense. I'm going to send it back because we have one more problem left in this video for you guys. Okay, this last problem deals with something that we talked about in class, the ambiguous case. When we are given triangles with two sides and one angle, we have an extra consideration to make. The sine function is positive in quadrants 1 and 2, meaning there are two possible angles whenever we take the inverse sine of a positive number. This is where the ambiguous case comes in. When given two sides and one angle, it is possible that there's one solution, two solutions, or even none. Alright, so for this last triangle, we're given sides A and B and angle A, and we want to work it to find angle B. Of course, given two sides and one angle, we will use the law of sines. Alright everyone, here we are in the final stretch. So this is the last triangle that we're going to work on. We have sides B and sides A, angle A, but we are looking for angle B. So we are going to use the law of sines. But this one specifically deals with the ambiguous case, so make sure you're paying close attention. So we start out pretty normal. We're going to go ahead, law of sines here. So we know the sine of angle A over side A equals the sine of angle B over side B. Oops. Okay, and what we do next, we plug in what we know. So we know that angle A equals 30 degrees. It's a pretty simple sine function there. And then angle A equals, side A equals 10. We do not know angle B, that's what we are on the hunt for, and we know that side B equals 16. So again, this is looking pretty normal, straightforward problem that we have dealt with in the past. So we're going to go ahead and cross multiply like we normally do. 16 times the sine of 30 degrees equals 10 times the sine of angle B. So I'll go ahead, pull up my calculator like I normally do. Let's clear all this out. So we'll go 30, sine of 30 degrees is 1/2. We're going to multiply that by 16, it's going to give us 8. Then we'll divide by 10, it's going to give us 0.8. These are some pretty simple calculations. So we know that sine B equals 0.8, but what's the other way we can write that? As the inverse sine function, right? So we can write inverse sine, a little -1 there, of 0.8, excuse my decimal point, equals angle B, and we know doing that will give us angle B. So this is where the ambiguous case comes into play. First of all, if we had gotten more than 1 for the quantity, let's say for the sine of angle B, like let's say this was 1.2 or something, that would be an issue because we know that the sine function is never greater than 1 and never less than -1. So that's a case where the triangle you're given doesn't exist. So if you get that, that the sine is more than 1, stop there. There's no reason to go any further. However, that didn't happen to us, so we can keep going. So the easy way to do this, of course, is to go to the inverse sine in your calculator. Hello. And what you do, there we go. So the inverse sine of 0.8 is 53.13 degrees. So we can say that angle B equals 53.13 degrees. Which checks out because our other angle here is 30 degrees, okay? So 30 plus 53 is 83.13, and that's less than 180. I'm going to go ahead and write that down. That 30 plus 53.13 is less than 180. Now, why is that important? Well, all the angles in a triangle add up to 180. So if it had been more than 180, that wouldn't be a possible triangle. So we know that this answer here, I'm going to go ahead and circle it in pink, this answer here works. That is a possible solution. So we're at a one solution triangle right now. However, the sine function is positive in quadrants 1 and 2, and the calculator does not take that into account. So you have to check the other angle, which is in quadrant 2. How do we do that? Well, we know we got 180 is all the way over to the second quadrant. So what we do to find that other angle where it equals 0.8 is you take 180 and you subtract that first angle you were given. So our other angle is 126.87. So I'll write that B also equals 126.87. Now, does this one work? So what do we do again to check it? Does that one plus the 30 degrees equal less than 180? So does 30 plus 126.87 equal, is that less than 180? Yes, it is, because that comes out to about 156, right? So that also checks out. We'll put a little check mark there, just for fun. So now we know that this angle works, but this angle works as well, which means we have two solutions for this triangle. This triangle, angle B, can be 53.13 degrees, or it can be 126.87 degrees. And then that also leaves two options for angle C. So this is where you have to really watch for the ambiguous case, is when you're given two sides and one angle, because you end up with an inverse sine function, and then if the number is positive, which it will be, you end up with two options, and you have to check both to make sure that they work, and that your triangle actually exists. So, those two angles add up to less than 180. So that's the ambiguous case. Again, something to watch for, and that's all I have for you now. So I'm going to throw it back for some reminders, and that's it. Congratulations, you've made it through to the end. So I'm going to close off with some reminders to get you ready for this upcoming quiz. So first of all, the video is on the law of sines. So of course, I'm going to talk about the actual law. So remember that the sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. Another important thing to remember is when to use the law. So the law of sines is used when you are given two sides or two angles. And last but not least, make sure to watch out for the ambiguous case. It's possible that your triangle will have two solutions, one solution, or even no solutions. So double check for the ambiguous case whenever you're given two sides and one angle. Alright, that's all I have for you guys, so continue on to the next part of this E-Day, and make sure that you're prepared for this quiz. Happy studying!
Created using PowToon.